Hello and welcome everybody. Today we'll be learning how we simulate a rainfall event with sub-areas in FloodArea. Right now you can see here our test area, which is by now only a DEM. And to integrate the sub-areas for our simulation, at first we have to make a mask out of that DEM. And we do that by reclassifying that raster. Our input raster will be our DEM. The reclass value is field is the value. We only want one class, and it's always useful if you round up your values so you're sure that every value that is in the raster is included. Same goes for the negative digits. Then you give our output directory. And important is to end the file name with a .tif. Then we set the environments. We give the output coordinates, which should be the same as the DEM. We do the same for the processing extent and for the raster analysis for the cell size. Here you can see now a new reclassified raster, our mask. Now we want this mask to be a polygon, and we do that with the tool raster to polygon. Again, our mask is the input raster, and we get an output directory. And here, important the SHP for shapefiles. Environment. We can get the output coordinates. And the rest should be fine. So now here's our polygon. And now we want to cut this polygon into three sub-areas to continue calculating with. So we start the editor. You can look into the attribute table, one polygon. We select it. And now we use the cut polygon tool, because there we won't have any problems with splinter polygons. Now we have two, and I want from here to there again, and now there are three sub-areas. Important for us is the grid code column in the attribute table, because here we will assign our hydrograph file for different irrigation values for each polygon. So by now it's for each of them 1. I want them to be 1, 2, and 3. It doesn't really matter what type of number you put in here. as long as it's in order, like 2, 5, 7 would be okay, or 11, 21, and 58, at, as long as the first one is always smallest, so FloodArea knows which one comes first. But for simplicity, it's recommended to just do 1 to 3. Okay, now we have our sub-area polygon, and now I want this polygon to go back to convert it back to be a raster. Before we do so, we have to save our edits and stop editing. So now here's our ready to go polygon. We want to change it back to a raster. We use the conversion tool. Our mask DM is our input file. Field value is the grid code. And our output raster name will be the sub area TIFF, because it's an raster file, and environments, again, output coordinates, same as the DM. We have a processing extent, and raster analyzers. So the cell size should be changed as well, as you can see here. And then we can calculate. And here you can see our new raster with sub-areas. Okay, now we have to modify the hydrographs for our different sub-areas. We already have an irrigation hydrograph here, but this one is only for one area. And we want, of course, an irrigation hydrograph for 3 different areas. So we create a copy, rename it, and open it with an editor. Now you can see here 2 different columns, one for time in hours and one for the irrigation hydrograph, which is in millimeters per hour. And we want to add in a second and a third one. This line here is just for your own orientation. It isn't read by FloodArea, so it doesn't really matter how you name this hydrograph. Important is the order the columns are in, because the first hydrograph column will be assigned to the first polygon. So this area here the middle one will get the first column, the northern one will get the second column, and the southern one will get the third column. So we have to keep that in mind. For the second hydrograph, I want a constant irrigation of 50 millimeters. So we want this for the whole hour. And after that amount of 1 hour, I want it to go down immediately. So I add in another line. at 1 hour and some seconds and tell it to drop to 0 at this time point in time. Important is that your simulation time starts with 0 and it ends at least at the same amount of time than the simulation takes. So here should be at least 3 hours. It could also be 10, it doesn't really matter. Because at 3 hours the simulation stops anyway, but we will leave it at 3 hours. And now I want to add in a third line for our third area, and there I want to be rainfall that's constantly increasing. So we start with 10 millimeters per hour, then we go up to 20, then we go up to 30, and so on. You get the idea. And after 1 hour, I want it to drop to 0 as well immediately. So here we have now our 3 different hydrographs. We save that. And now we have to give FloodArea also a time switch text file. We copy any text file, rename it to discharge text. We open it, we can delete that, and we only need 2 columns, one for time and one for a path. For the time, this time it's in seconds, not in hours, and we want 5 minutes time steps, so we start with 300 seconds, and then we have to give a path to where our discharge indices are stored. So we copy that path and then we have to type in the name of our second discharge index, because the first one will be already used by FloodArea when we start the simulation, and then after these 300 seconds it will switch to the second raster, which is this one. So type in the name. And don't forget to add the .tiff. We copy that line and put it in for 11 times. So it adds up to 12 time steps with the one FloodArea starting with, and so we have 1 hour of simulation. Then we have to change the time in steps of 300 seconds. And another one for okay, after we change the time, we now have to change the names so it can jump from one TIFF to the other. So we just change the numbers in the end. Okay, and now we have a ready text file for our time switch. Save it and then return to ArcGIS. Okay, now that we prepared our input data, we can start the simulation. We do so by opening the Arc toolbox, clicking on the FloodArea toolbox and clicking on Start FloodArea. Here we have to give our input data. We start with the DEM. These default settings stay the same. we have to give output path for our temporary data. So we create a new folder for that. Same goes for the output directory. The output switch, we have some switches to choose from, and we want to use switch number 4, which will give us the inundation depth, the flow direction, and velocity. Maximum exchange rate per mil will be 1. Starting time stays at 0. Duration will be 3 hours. Simulation in seconds that's 10,800. Saving interval will be every minute, so every 60 seconds. We keep the default settings here. We want to include a roughness raster. We don't want any of these, but we want to activate the rainfall option. Our discharge index raster, we put in the first one of the 12 we have. The rainfall hydrograph, that's the one with the 3 different hydrographs for each sub-area. And the discharge index time switch is the text file we just prepared, which tells FloodArea when to switch from which discharge index to the next. So that's this one. We have multiple rain hydrographs, so we also have to give FloodArea our sub-area raster. And we can start our simulation. And if you click on results, you can see that the process is calculated by now. So that's all, and thank you all for watching.